Hello friends, let's have a look at problem 2658, maximum number of fish in a grid. This is a traversal problem, so you can regard this grid as a graph, and each cell has 4 neighbors if all the neighbors are inbound, right? So here, if a cell has a value 0, it means a land, and if it has a value greater than 0, it means it's water and it contains this amount of fish. So a fisher can start at any water cell and it can do the following operations any number of times. So it catch all the fish at that cell and move to any adjacent water cell. So we want to return the maximum number of fish the fisher can catch if he chooses his starting cell optimally, or 0 if no water cell exists. So if you look at example 1, so if you start from position 0, 1 or 0, 2, you can collect all the 3 fishes in these 2 cells. So if you start from 1, 0 or 2, 0, you can collect 5 fish. So if you start from 3, 1 or 3, 2, you get 5. And you start from 1, 3 or 2, 3, you can get 7, right? So overall, it will be 7. So similarly, you can interpret example 2, the return is 1. So here, this problem has a very small size. So here, the number of rows and number of columns are both bounded above by 10, right? So overall, we have 100 cells. So with that said, I guess we are ready to do the coding. So first, I'm going to see, we're going to use Traversal. So you can use breadth-first based traversal, or you can use depth-first based traversal. And also, you can write in iterative format or in recursion format. So in this video, I'm going to use recursion. So with that said, basically the idea is to do the traversal by considering all the different positions. So once you do this traversal, and you're going to change some values of the water to be land, and then you can finish the comparison of the maximum fish you can get. So with that said, let me first get the number of rows and the number of columns. So this is very standard, right? So here I'm going to write a hyperfunction, let's call it DFS, so from a position, right? So basically, we want to check if I started from this position. So we want to check how many fishes we can get. So let me do this. If R is out of bound, so this position is out of bound, so it means R less than 0, or R greater than or equal to M, or C less than 0, or C greater than or equal to n. So this is the one. Or if grid RC equals 0. So in this case, I just need to return the results 0 automatically. Otherwise, what we do, we're going to add the current number of fish to the result variable, and then we can set result RC to be 0, or you can set other values, but you do some check. So then what we do, so basically we traverse the 4 possible neighbors. So DFS R minus 1 C result add DFS R plus 1 C, and result DFS R C minus 1, and the result DFS R C plus 1. Wait, let me write it like this. So then we just need to return the final state of this result. So this is the hyperfunction, and now we just need to traverse all the positions. So basically, let me initialize a result variable, initially 0, and then for I in range n, not in m, for j in range n. Then basically, if grid ij is not 0, right? Because if 0 is either originally a land or we have visited. So what we do is result equals max result and DFS this ij, right? And then what we want to return is just the result. So here actually we can change the name a little bit. So I can see final result, final result. It might be better because here I use result, final result. So now let's do a quick test. Yeah, it passes the 2 test cases. Now let's look at the generic case. It's wrong. Let's see what's the problem. So here max r minus. So here I guess I write C+1. Let me run it again, and then we submit. Yeah, it passes all the cases. So here, actually, the thing one thing I want to mention is that when we do this DFS function, actually we modified the grid, right? So in other words, when you do this for loops, actually due to this if check, actually a lot of positions it directly returned, right? So with that said, I guess that's about it for the current video. You're welcome to modify the code or write some solutions using iterative format. That's a good practice, I think. With that said, that's it. Thank you for watching.